Assalamu alaikum, it's Ahlam Deeb, and I'll be explaining Chapter 2, Rate of Reactions, Part 5. Before we start, please prepare your stuff. In our video for today, we are going to practice some relations in kinetics. In this typical exercise, a solution S is prepared by mixing 3 reactants according to the following reaction. Our objective for today is to verify these 4 relations. Let's start with the first relation. We have here the given of the exercise. We have the 2 reactants, oxalic acid and potassium permanganate. We have their concentration and the volume of the solution. We have V molar equal 22.4 liter per mole, and the equation of the reaction that takes place. Let's see the first relation that we have to verify. We have to verify that the concentration of H2C2O4 at instant t is equal to 5 times 10 to the power minus 2 minus 5 over 2 the concentration of Mn2 plus at the same instant. H2C2O4 is a reactant in this reaction, while Mn2 plus is a product. Let's remember something. We know that when I write the number of mole of H2C2O4, which is a reactant at instant t, I mean this number of mole that remains at this instant. Why H2C2O4 is a reactant, while for Mn2 plus, the number of mole of Mn2 plus at instant t means the number of mole formed or produced, since Mn2 plus is a product. Please remember these when you work with relations. Also, you can always write this relation for a reactant. The number of mole of the reactant left at T is equal to the initial number of mole of this reactant minus the number of mole which has reacted. So for H2C2O4, I can start like this. The number of mole of H2C2O4 left at instant T is equal to the initial number of mole of H2C2O4 minus the number of mole that has reacted. If I compare it with the relation that I have to prove, I have started well, but here I have to replace H2C2O4 reacted by Mn2 plus. I can refer to the stoichiometry of the reaction, which says the number of mole of H2C2O4 reacted over 5 is equal to the number of mole of Mn2 plus formed over 2. So the number of mole of H2C2O4 reacted is equal to 5 over 2, the number of mole of Mn2 plus formed. Instead of formed, I can put T, since Mn2 plus is a product. Now I can replace this by this to get the following relation. Now this relation is very close to this one. I have to change the number of mole by concentration. This would happen when I divide by V total. So the number of mole divided by V total will allow me to pass to the concentration, and I will get the concentration of H2C2O4 at instant T equal to the initial concentration of H2C2O4 minus 5 over 2, the concentration of Mn2 plus at instant T. Now, we still have to get this value. So the concentration, the initial concentration of H2C2O4 is equal to the initial number of mole over V total. We have seen this before. So it is equal to C1 times V1 over V total equal to 0.1 times 50 times 10 to the power minus 3. V total is equal to V1 plus V2. It is equal to 50 plus 50. We multiply by 10 to the power minus 3 to convert to liter, and we will obtain 5 times 10 to the power minus 2, which is this value. So we can replace it to have the relation I want to verify. Now, the second relation in our video, the relation is between MnO4 minus at instant t which is the reactant remaining at this instant, and V of CO2, which is the volume of CO2 produced at this instant. So the relation is between the reactant left and the product formed. And we want to start by the reactant left. So I can start by saying that at any instant T, the number of mole of MnO4 minus at T is equal, and since it is a reactant left, so it is equal the initial number of mole minus the number of mole that has reacted, okay? So I have started like the beginning of the relation that I want to prove by saying N of MnO4 minus at instant T. Now I have to replace MnO4 minus reacted by CO2, and I know that the stoichiometry of the reaction will help me, because according to the stoichiometry of the reaction, the number of mole of MnO4 minus over 2 is equal to the number of mole of CO2 formed over 10. Always when you want to start with a relation, start with the number of mole. So the number of mole of MnO4 will be equal to, we will simplify 2 and 10 to have the number of mole of CO2 over 5. Instead of formed, I can put T, since CO2 is a product. Now, I can replace this by this one to get this relation. I have to substitute number of mole here by V, and I know that the number of mole of a gas is equal to V over V molar, so I can replace it by V over V molar. The 5 remains here. Now we have to put the numbers, but first I have to convert the number of mole into concentration. How? It is easy. I have to divide by V total. So the number of mole of MnO4 minus at instant T divided by V total will give me the concentration of MnO4 minus at instant T. The initial number of mole divided by V will give me the initial concentration, minus here to this fraction I have to add V total in the denominator. Okay, so V total appears here, since I don't have number of mole to have concentration. Now we are going to put the numbers. 5 times V molar 22.4 liter per mole. Pay attention that V of CO2 is in liter, so I am obliged to put the V total in liter also. So V total is V1 plus V2, 100 milliliter, times 10 to the power minus 3 to have it in liter, and V of CO2 here is in liter, so I will simplify liter by liter, and here the unit liter per mole will be mole per liter, which is the unit of concentration. So, okay, these numbers are correct. I still have to calculate the initial concentration of MnO4 minus, which is equal to the initial number of mole over V total. It is equal to C2 V2 over V total. So this is the number. So I will have 5 times 10 to the power minus 3 minus 1 over 11.2 is equal to 8.92 times 10 to the power minus 2 V of CO2 at instant T, and T is in liter. Now, the third relation in our video, the concentration of Mn2 plus at instant T, which is a product formed, and the volume of CO2, which is also a product formed. So the relation is between a product formed and another product formed. So I can get the relation between two products formed by referring to the stoichiometry of the reaction. And I will start by Mn2 plus, since it is in the beginning here in the relation. So I will say that the number of mole of Mn2 plus formed over 2 is equal to the number of mole of CO2 formed over 10. By simplifying these two numbers, I will get that the number of mole of Mn2 plus formed is equal to the number of mole of CO2 formed over 5. Instead of formed, I can put T, and instead of N, I will put V over V molar. So this is the relation. I still have to convert N into concentration. How? By dividing by V total. The number of mole divided by V total will give me the concentration of Mn2 plus at instant T. And here I have to put V total since I don't have number of mole to put concentration. Let's put these numbers in their values, but we have to pay attention here. Why? Since in the given they have told us that the volume of CO2 is in milliliter, so I have to leave V total in milliliter. Why? So I can simplify milliliter and milliliter, and V molar is always in liter per mole. So the unit of the concentration will be mole per liter, which is correct. So please here pay attention. Do not convert V total into liter. Keep it in milliliter since the V of CO2 is in milliliter. And if I multiply these three numbers, I will get the relation that I have to prove. Finally, the last relation in our video, it is between the concentration of Mn2 plus at instant T, which is a product formed, and H2C2O4 at instant T, which is a reactant left. I have to start my relation by Mn2 plus at instant T, which is a product. So I have to start by saying, according to stoichiometry, the number of mole of Mn2 plus over 2 produced or formed over 2 is equal to the number of mole of the reactant reacted over 5. So I repeat, according to stoichiometry, the number of mole of Mn2 plus formed over 2 is equal to the number of mole of H2C2O4 reacted over 5. But here I wanted in function of the reactant left and not reacted. Pay attention how we are going to replace it. But before, let's write here N of Mn2 plus formed alone. So the 2 will be here next to the number of mole of H2C2O4. So the number of mole of Mn2 plus formed will be equal to 2 over 5, the number of mole of H2C2O4 reacted. Instead of Mn2 plus formed, I can put T, since it is a product, remember this. And H2C2O4 reacted, I have to replace it. How? By writing, instead of N, number of mole of H2C2O4 reacted, which is equal to the number of mole, or the initial number of mole of H2C2O4 minus the number of mole of H2C2O4 remaining or left. So I replaced this by this. I will multiply 2 over 5 by these two. So I will get that the number of mole of Mn2 plus at the instant T equal 2 over 5, the initial number of mole of H2C2O4 minus 2 over 5, the number of mole of H2C2O4 remaining. Instead of remaining, I can put T since it is a reactant. Now, let's look to this relation. I want to pass from number of mole to concentration, so I will divide by V total. So I will get, instead of number of mole here, I will get concentrations, okay? So the concentration, concentration, and concentration. By making a comparison, I still have to get this value. How? By calculating the initial concentration of H2C2O4, or the initial concentration of H2C2O4 is equal to the initial number of mole over V total equal C1 times V1 over V1 plus V2, and we multiply it by 10 to the power minus 3 to convert it into liter. So we will get this value. Let's put it. So 2 over 5 times 5 times 10 to the power minus 2. We simplify by 5. So we will get 2 times 10 to the power minus 2 minus 2 over 5 H2C2O4 at instant T. This is the last relation for today. We came to the end of our video. Please copy these 4 relations on your copybook and study them well. See you soon in the next video. Wassalamu alaikum.